Alright, here we are going to solve each inequality algebraically, and then we are going to represent our solution on the number line. So, the first one, 7 plus 10x is greater than or equal to 47. Remember, we solve these inequalities just like we would solve an equation. There's only like one major change when we're doing it, which we'll talk about it if it happens. So, other than that, you just want to solve this just like an equation. So you want to get x on one side of the inequality symbol by itself. So here, 7 plus 10x is greater than or equal to 47. The first thing we want to do is take the 7 and move it to the other side. So it's a positive 7, so to move it to the other side, we subtract 7 from both sides of the inequality symbol. When we do that, these 7's cancel out. So we have 10x is greater than or equal to 40, because 47 minus 7 is 40. Now we have 10 times x is greater than or equal to 40. The inverse of multiplication is division. So to undo our multiplying by 10, we're going to divide by 10 on both sides of the inequality symbol. So we can divide by 10. 10 divided by 10 gives us a giant 1. So 1x, which we just write as x, is greater than or equal to 4. So now that we have that solved algebraically, we're going to take it and put it on the number line. So first we're going to put a circle at 4. We need to figure out if it's opened or closed. To do that, we want to say, does 4 make our inequality true? So let's test it. Is 4 greater than or equal to 4? Yes, because 4 is equal to 4. So we can fill in the circle. And now we need to figure out which direction we want to shade. So let's plug numbers in for x and see if they make the inequality true. So let's first start with over here. Let's start with 0. Is 0 greater than or equal to 4? No, 0 doesn't work. Is negative 4 greater than or equal to 4? No, negative 4 doesn't work. So it doesn't look like any numbers to the left of 4 here are going to make our inequality true. Let's check some numbers to the right. Is 6 greater than or equal to 4? Yep. Is 7 greater than or equal to 4? Yep. Is 5 greater than or equal to 4? Yep. Should I shade to the right of 4? Yes. So to put your solution on the number line, you're going to shade all of the numbers here that are bigger than or equal to 4. All right, number 2. Number 2 says negative 4x is less than 20. So again, we want to solve this algebraically. And here we need to be careful because we need to divide by a negative. So negative 4 times x is less than 20. The inverse of multiplication is division. So to undo multiplying by 4, we divide. To undo multiplying by negative 4, we're going to divide by negative 4 on both sides of the inequality symbol. When you divide by a negative number, you have to flip your inequality symbol. So instead of less than, now it's going to say greater than. So we're going to flip the symbol because we divided by a negative, and now let's see what we have. Negative 4 divided by negative 4, that's a giant 1. So we have 1x, which we can just say is x is greater than, because we had to flip the symbol, negative 5. 20 divided by negative 4 is negative 5. So now that we've solved this algebraically, we can take the solution and graph it on the number line. So we can represent this solution on our number line. So we're going to start at negative 5 and we're going to put a circle there. We need to figure out if it's opened or closed. To figure that out, you ask yourself, does negative 5 make this inequality true? Is negative 5 bigger than negative 5? No, it's not. So we are not going to fill in the circle. Now we need to figure out which direction we have to shade. So let's test some numbers here to the left of negative 5. Is negative 7 bigger than negative 5? No. Is negative 6 bigger than negative 5? No. So it looks like the numbers to the left don't make our inequality true. So we're probably not going to shade that way. Let's check the right. Let's start with 0. 0 is a nice number. Is 0 bigger than negative 5? Yep. What about 5? Is 5 bigger than negative 5? Yep. Negative 3. Is negative 3 bigger than negative 5? Yep. Are all the numbers to the right of 0 here on, to the right of negative 5 here on our number line bigger than negative 5? Yes. So all of the numbers in this direction here make the inequality true. So I'm going to shade this way and put an arrow on the end because the solutions keep going in that direction. And that is our final answer. So for each of these inequalities, we solved them algebraically and then represented the solution on a number line.